Hi everyone, my name is Reza Chen. I'm a third-year PhD student from University of Michigan. Today I'm going to tell you about WorldScribe, a system towards generating context-aware live visual descriptions for blind people to access the real world. This work was done with Yuxian Liu and my advisor, Anhong Guo. So understanding the real world can be challenging for blind individuals. While they can take photos and use AI models to generate descriptions such as in ChatGPT, Be My AI, or Seeing AI, this approach often leads to turn-by-turn asynchronous experiences, where the environment may have changed significantly by the time the model responds. And the generated descriptions are one-size-fits-all. They may not take the user's dynamic context into consideration. To access context-aware live visual descriptions, blind people often rely on sighted assistants like Aira and Be My AIs. However, human assistants are expensive, not always available, and raise privacy concerns. In this work, we present WorldScribe, a system that generates live visual descriptions based on user context. Let me play the video to quickly demonstrate its key capabilities. The user who wants to find a beige backpack can specify their intent to WorldScribe.
Find beige backpack on the chair.
First, when the user is moving and the scene changes quickly, WorldScribe provides shared descriptions with object labels.
TV, refrigerator and cabinet.
Then, when the visual scene becomes more stable, WorldScribe will gradually provide more details with objects and special relationships.
A modern kitchen and dining area features a white countertop, sink, and refrigerator with a wooden floor, white walls.
When there are lots of objects in front of the user, WorldScribe will prioritize based on proximity and provide consecutively succinct descriptions.
Coat hangs on wall. Countertop holds various items. Wall speakers are mounted.
Then, when the user stops to focus on objects of their interest, WorldScribe will provide longer descriptions, including rich visual details.
A black backpack with textured fabric features 2 prominent zippers and adjustable straps.
At the same time, to help the user better perceive the spoken descriptions, WorldScribe will adapt to the sound context, such as increasing volume over music.
Cat. A light brown cat sits on a black metal railing, gazing at the camera, with a white door and white walls in the background.
So in the video, there are descriptions with different information richness, such as shared object labels, general descriptions with objects and their special relationships, and detailed object descriptions with rich adjectives for describing their visual attributes. They were enabled by 3 levels of models with different information richness and latency. So these descriptions were generated, prioritized, and presented based on user's context. With user intent, it generates 3 levels of descriptions. In different visual contexts, WorldScribe prioritizes shared descriptions if the user moves, or provide long descriptions when the user remains static. Based on the sound context, it presents descriptions with increased volume if they are noisy, or poses descriptions. Let me briefly explain how we implemented this in WorldScribe. First, the user talked to WorldScribe about their intent, and WorldScribe decodes it into relevant object classes and visual attributes. Next, we want to simulate a visual cursor where the user indicates their visual interest by the camera movement, such as exploring generally with dynamic movement, or focusing on something to indicate their interest. To achieve this, we would like to extract keyframes to understand the user's visual focus. Given a camera stream from user's smartphone, we can use YOLO World and ByteTrack to check these objects with their IDs and classes as outputs. To detect the keyframe, if the object composition in consecutive frames are the same, then we take the latest one as keyframe. Another intuitive way is to track the view orientation by the smartphone sensor If the difference of orientation exceeds 1 clock unit with significant visual changes, then the latest one is also a keyframe. So now we have the keyframe. We feed this keyframe to different models to get descriptions of different level of richness. We already have the object labels detected by Yellow World. Then WorldScribe get the general descriptions from Moondream, which is a tiny visual language model that can generate decent general descriptions in a short time. And we can get the detailed object descriptions by prompting GPT-4 Vision with visual attributes of users' interest. So if the user just moves to this visual scene and stays for a while, then this is the descriptions they will receive.
A backpack, a chair, a table, a vase, and a glass. A wooden table with a vase of flowers, a glass of beer, and a backpack rests on a floor. A black backpack rests against one of the chairs, featuring various straps and a textured surface that suggests utility and ample storage for carrying personal belongings.
The user can also hear more details about other objects if they stay a longer while. But if the user moves to other visual scenes without finishing all descriptions, then they will constantly receive short descriptions, just like what you saw in the beginning of the video.
Backpack, a chair, TV, pot, a refrigerator.
To present descriptions, WorldScribe also considers sound context, where users can predefine either increasing volume or posting descriptions based on different sound events on customization interface, so that the user can better perceive the descriptions or sounds in the real world. So I just gave a general idea here. Please refer to our paper for more implementation details. We conducted a user evaluation with 6 blind people to understand how do users perceive WorldScribe descriptions in various contexts, and what are the gaps between WorldScribe descriptions and users' expectations. We conducted a user study in 3 different contexts, such as having a specific intent when exploring our lab, or having general intent when exploring in the hallway of our building. And lastly, the user defines their own intent and where to explore in our department building. Overall, participants perceive WorldScribe descriptions to be accurate based on the contextual clues they are certain. For instance, without vision, one participant put her hand within the camera view to evaluate the responsiveness and accuracy. She said, "I just wanted to test if it can describe the rings on my hand. It did describe and did a pretty good job and so responsive, so I think it's accurate for what it is." Also, participants found WorldScribe descriptions useful with adapted and customized visual information. As P1 said, it's interesting when it just provided only a few words when I moved or turned, like a desk, a chair, a person. It's nice to know what is included in this space, and I got details if I faced that for a little longer. I like the switch between these low-level and high-level descriptors. If I'm in the moment that I should picture things myself, it will just give me low-level descriptors. Some participants also thought WorldScribe provided experiences otherwise unavailable from existing apps. As P2 said, it's closer to seeing AI and Be My Eyes descriptive mode. Initially, it's like desk, chair, and become descriptive like a human. More color and context if you are looking at things longer. For second research question, we found that users' intent change dynamically based on the information they receive, instead of just a sentence specified at the beginning. So we should develop ways for users to update their intent on the fly in the future. And second, participants were confused that the descriptions repeated when they returned to the same places without indicating they had been there before. For example, they expected to hear some heads up like, "Oh, you came to here before," and they want to hear like only visual changes instead of describing all the things again. The special information was centered on the given frame, but not the user. So the directional information, such as left and right, in the description was confusing. Future work could consider like how to take the video stream to build a 3D scene in real time to answer the direction-related questions. Please refer to our paper for more details about evaluations. So through this work, we also recognize promoting real-world accessibility through live visual descriptions will be a long-term overarching problem. And there are improvements we could make given the current trend of technologies. So first, as large models are becoming faster and more accurate, it's worth exploring how to dynamically change the prompt based on context that can provide proper information richness and focus. Such contextual prompting could increase descriptions utility, and we could embed domain-specific knowledge into descriptions, such as giving directions or landmarks sourced from the external maps during navigation, or providing history background or using rich adjectives for describing artworks. Descriptions should also be timely in urgent or high-stakes situations and adapt in detail, such as describing which traffic light is lit rather than all of them. And third, smart glasses could be a promising alternative to smartphones, which users may struggle to aim correctly. It can provide egocentric perspective that could help WorldScribe to offer more personalized experiences based on users' hands-on activities. So in conclusion, we present WorldScribe, a system that provides live visual descriptions based on users' context. It considers users' intent to generate relevant visual descriptions. It draws from visual context to prioritize descriptions. It also considers sound context to make descriptions easier to hear. So thanks for your attention, and I'm open to questions.
All right. Thank you. And I think we have time for only one question. So.
Just a quick one. Rolf Vertical, Human Media Lab. Great work. My question is, are you sending images to ChatGPT, or are you using the YOLO descriptions to feed it in?
Yeah, we are sending the images to GPT-4 Vision to get
so you sent the full image there?
Yes, the
okay.
full image. Yeah.
Okay, thank you.
Any other questions?
Very inspiring talk. Thanks. I'm Riku from Carnegie Mellon University. So my question is about, like, you are using YOLO model to fast detect the object,
yes.
Right? So YOLO model, I guess, sometimes it cannot capture the object that the participant is looking for.
Yes.
How did you observe any cases in your user study, like such a YOLO model couldn't find the target object, so the participants struggle in finding the object or something?
Yes, the first participant in our study, he is a low vision user, so he put his eye drop in front of the camera, and our system cannot capture that. So it's kind of decreased his confidence in our system.
How would you address those inherent issues in the object detection model in the design in the future?
Yeah, I think right now we generate these object classes based on users' intent, but we can also include as much object as possible in the futures, by default.
Mm.
Yeah.
Okay. Thank you.
Thank you.
Thank you.